Hi students, I am Sumalata. In today's class, I am going to teach you about Mendeleeff's periodic table. In previous class, we have already discussed about classification of elements by other scientists. Once you can check that one also for clear idea. Actually, Mendeleeff tried to classify well-known elements at his time based upon their atomic weights. He proposed one law. What is that law? The law is nothing but physical and chemical properties of the elements are periodic functions of their atomic weights. This means he tried to arrange the elements increasing order of their atomic weights in his chart. His chart was divided into 8 vertical columns. These vertical columns are also known as groups, and these groups are indicated with Roman numerals 1 to 8. And another one is 7 horizontal rows. 7 horizontal rows. These rows are known as periods. These periods are indicated with Arabic numerals 1 to 7. Now coming to the vertical columns are groups. These vertical columns are groups again divided into subgroup A and subgroup B. Nothing but each column divided into 2 subcolumns. One is subcolumn A and subcolumn B, or subgroup A and or subgroup B or subcolumn B, like that. See, actually the elements present in same column are having similar chemical properties. How can you justify this one? All the elements in the same column having similar chemical properties. See, if once you take group 1 elements, if group 1 elements are reacting with oxygen, they will form oxides. Their oxides general formula is the R2O. What are the group 1 elements? See, lithium, sodium, potassium, rubidium, cesium, francium, etc. See, if lithium reacting with oxygen, the oxide is the Li2O, sodium Na2O, potassium K2O, Rb2O, and Cs2O, like that. You can remember it. If you can take group 2 elements also, group 2 elements are, if they are going to be reacting with oxygen, the general formula of their oxides is the RO. Once you can take group 2 elements, beryllium, magnesium, calcium, strontium, barium, radium. See, beryllium reacting with oxygen, BuO will form, magnesium forms MgO, calcium forms CaO, strontium forms SrO. By seeing these oxides, we can easily conclude the elements present in the similar column are having similar chemical properties. Okay, this is about groups present in the Mendeleeff's periodic table. The next one is the periods. The elements present in a period are having different chemical properties. Periods are having entire range of elements, after which their property is going to be repeated. That's it about periods. Coming to the next salient feature of Mendeleeff's periodic table, he tried to predict properties of some unknown elements by leaving some gaps for those elements at his table, and he proposed some names by adding the prefix Ika to the name of that element. Once you see Ika boron, Ika aluminium, and Ika silicon. See, later on this Ika boron was named as scandium, and Ika aluminium was named as gallium. Next, Ika silicon was named as germanium. And how his predicted properties and observed properties going to be similar or not. Once you see here, you can take Ica aluminum and Ica silicon. If Ica aluminum reacting with oxygen, so it will forms oxide Ea2O3. If gallium reacting with oxygen, it will forms Ga2O3. See, oxide will going to be similar. And atomic weight you can take, this is the 68. This one is the 69 point someone is there, and its density is 5.9. Its density is the 5.94. Both are maximum similar, and its chloride is EaCl3 and its chloride is GaCl3. See, maximum almost all properties of Ica aluminum and gallium are going to be similar. Suppose you can take silicon, Ica silicon and germanium. Ica silicon forms EsO2 oxide, germanium forms GeO2 oxide. Its atomic mass is 72, its atomic mass is 72.94. And here its mass is density is 5.5 and its density also 5.49. And here also it will also form chlorides. The chloride is EsCl4, germanium form chloride GeCl4. See, maximum almost all properties are going to be similar. Observed properties of that element and predicted properties of that element. Now coming to the next salient feature of Mendeleeff's table, his arrangement was helped in the correction of atomic weights of some elements. You can see one example here, beryllium. Actually, beryllium atomic weight was observed as 13.5 students. How it is 13.5? You can see atomic weight formula is equal to equivalent weight into valency. Actually, scientists thought that its equivalent weight is 44.5 and its valency is 3. Then it will become 13.5. See, 3 5s are 15, 1 3 4s are 12, 13.5 U. But it was the wrong one. Its atomic weight is not 13.5. Its atomic weight is 9. It was the right one. He corrected this atomic weight 13.5 into 9. How it will going to be corrected? See, he said its valency is not 3, its valency is 2. Then its atomic mass going to be 9. See, 2 5s are 10, 1 2 4s are 8, 9. See, 9.0 U is its atomic weight. If its atomic weight is 9 and its valency is 2, then it is going to be fit in the group 2 elements. The group 2 elements are nothing but magnesium, calcium, strontium, these elements. So, if it is going to be fit into group 2 elements, it will go, the all properties of beryllium and other group 2 elements are going to be similar. And his work also helped in the correction of other elements atomic weights. What are those? See, indium and gold also. Their atomic weights were also corrected by Mendeleeff's chart. These are about salient features of Mendeleeff's periodic table. Next one is limitations of Mendeleeff's periodic table. What are those? You can see here. The first one is, in his chart, scientists observed some anomalous pair. Anomalous pair is nothing but, you can see some examples. See, tellurium you can take, iodine you can take. Tellurium's atomic weight is 127.6. Iodine's atomic weight is the 126.95. See, actually his table mainly based upon increasing order of their atomic weights, not decreasing order. Here he arranged tellurium before to the iodine, but it is not the right arrangement. This is one of the minor mistakes. So these two elements are the anomalous pair. First we have to arrange less atomic weight, then after more atomic weight. But here it is the reverse. And the next limitation is some dissimilar elements were placed in the same column. What are those ones you can see? Suppose you can take group 1 elements. Group 1 elements are nothing but lithium, sodium, potassium, etc. These are known as the alkali metals. Alkali metals. These alkali metals were placed together with the group B. Those elements are nothing but the coinage metals. These are the group 1, subgroup A and subgroup B elements you can see. Those are copper, silver and gold. See, these elements are the coinage metals. But these two, I mean group A and group B, those are having little resemblance with their properties, not complete resemblance. But if you take chlorine is the group 7th A group element, manganese is the 7th B element. This chlorine is the non-metal, this manganese is the metal. Both are existed in the same column. Same column or same group. That group having two subgroups, you already know. That subgroup A and subgroup B. This is the non-metal and that is the metal. These two are the completely dissimilar elements. This is one of the major drawback. These are about limitations. After that, is it agree or not? Nothing but his work was accepted by scientists or not? That is the question. Yes, his work was accepted by scientists. Because of his work, with respect to him, they named 101st element as Mendeleevium. Mendeleevium. 101 element name is the Mendeleevium. This is about Mendeleeff's periodic table. I hope you are all understand about this one. If you have any doubts, don't forget to post your doubts in comment box. Like, share these videos to your known people. That will makes me more energy to make some more sessions. Thanks for watching. We will meet in the next class. Bye, I love you.